It is 10 o'clock, so I'm going to start talking, and I did start the recording, if you're wondering. I've taught this lesson 3 times, and every single time I've forgotten to start the recording. So, here we are. I do want to point out these recordings to you. These are the videos from last week. So if you get stuck on anything and you're not sure what to do, or you need to go back and review, you have that option to go back here and review. Now, some of them overlap a little bit, but all topics are covered. So they do overlap a little bit, but they are covered. So these are the videos for last week. This video will go up on our announcement for this week. So speaking of this week, remember to get information about the class. You need to go to announcements. And it now says class overview for the week of January 21st. That's this week. And this is more of what you can expect from me now that I'm not going home and sleeping every day after class because I'm sick. So this class overview is going to kind of tell you what's coming, what you need to focus on, where we're going, and all that good stuff. So this week, you've got quiz 0 due on Friday, January 25th by noon, okay? Don't wait until Friday. Don't wait until Friday. Go ahead and get that taken care of. You do have to print it and fill it out. And I've had lots and lots of people come and do that. I have office hours today right after this class from 11 to 12:30. And then I have office hours tomorrow at 8:30 in the morning and then again at 1 tomorrow afternoon. So lots of opportunities, but you do want to go ahead and get that taken care of. This right here, Solutions, page 40, Math 131. That is that very first assignment that we did where we were adding and subtracting. There were some fractions in there. There was an order of operations. It was that assignment that I said was not going to be turned in for a grade or anything, but it was a good review for you. So if you need those solutions, and by solutions I mean I've worked them out. Like it's not just the answers. It shows you how to do it. Okay? Do you see that? Do you see how it shows you how to do it? Okay, so all of your homework, you'll be given solutions to that homework. So if you got stuck on any of those and you need to review those, there's the solutions. Now, here's your homework for Chapter 2, right here, page 101 to 103. I had a couple of situations where I had students that are veterans and they were waiting for their military funds to come in to purchase books. Unfortunately, our government is closed, and so that money is not coming until our government reopens. So I decided to go ahead and upload your Chapter 2 book assignment. I'm not doing this for you to not purchase the book. I'm doing this because our government is shut down, okay? So you do have to purchase the book, and as soon as things are up and running again, then I won't be able to do this anymore. But I did do it for Chapter 2. So if you don't have the book, you can still do your Chapter 2 assignment. Okay? But again, I can't continue to do that. I'm just doing it because of the situation that we're in right now. Okay? This is the solutions to that. Okay? This is the solutions to your Chapter 2 homework. It does no one any good to print that off and recopy it and turn it in. Okay? That just means you're going to fail the test. But it's very helpful for you to be able to see the solutions as you're studying. So that's why I put that up there. So be an adult. Make sure you've mastered the material because 100% in homework is not going to get you anywhere if you're not doing well on the test. So that is a tool. That is a tool for you to have. Okay? Homework Chapter 2 is due next Friday. Your test Chapter 2 is next Friday. So we've got that kind of coming. Any questions on kind of administrative, what this looks like, anything like that? Definitely click on quiz 0. I've had a couple people with, it's kind of a weird situation where it says they're blocked or something. Send me an email and just say, hey, Alicia, email me quiz 0. Okay? I don't know what it is. It's some people, they get blocked and some people don't. So just email me. You can send me an email right now and I'll I'll send quiz 0 to you so you can print it and fill it out. Okay? If anybody gets that, if you'll send me a screenshot, I'll take that to the Canvas people and see if I can figure out what's going on. I don't have any idea what's going on because a significant number of people are able to print it out. So I don't know what that is. Okay, administrative questions on what's happening in life. You're like, yeah, good luck with that.
Yeah, you're saving about $20 right now.
Oh, good. Only for another week or two, though, right? Right?
Yeah, let's go with that.
Yeah, we're going to go with that. Yeah.
I'm just kind of stressing over this textbook because one textbook here costs pretty much my entire paycheck. I work for minimum.
This textbook, you can rent it for $28.
I'm the type of dude to have that be half my paycheck.
Okay. So Doodle has it also. Doodle has it to where you can get it really cheap.
Okay.
So Doodle for like $20. So, yeah.
Thank the Lord I don't believe in.
Okay. So we've talked about formulas, we have talked about equations, and we have talked about inequalities. Today we are going to talk about compound inequalities. So before we start talking about compound inequalities, I want everybody to kind of look and see what you've got on. Yes, your clothes. If you have on jeans and a sweatshirt, I want you to stand up. So if you have on a pair of jeans and some type of sweatshirt, I want you to stand up. Okay? So we have three people that have on jeans and a sweatshirt. So for this group to stand up, they had to meet both criteria. They had to have on jeans and they had to have on a sweatshirt. Now, if you have on jeans or a sweatshirt, I want you to stand up. Jeans or a sweatshirt. Good.
Sick threads, bro.
Jeans or a sweatshirt. Now, the people that are standing up now only had to meet one of those criteria. So we have a larger group standing up because they didn't have to meet both. They only had to meet one of those criteria. Okay, you can sit down. Thank you very much for standing up for me. So, that's what we're talking about today, is compound inequalities. So, we are going to take two requirements, and it's going to be numeric, and we're going to put them together. And sometimes we're going to be talking about both requirements. Okay, sometimes our number is going to have on a pair of jeans and a sweatshirt. Okay, and sometimes our number requirements are going to be or, where you have to have on a pair of jeans or a sweatshirt. Okay, so I want you to kind of start thinking about what the word and means and what the word or means. What the word and means and what the word or means. Now, we are going to continue working with interval notation. And what I want you to know is the interval notation for the word or is a U. That's what this is right here. It means union. Union. Okay? So in interval notation, that is going to be important. So while we get started right here, I want us to look at this. I've got x is less than -1 or x is greater than or equal to 3. So what I'm going to do right now is I'm going to draw a number line. Here's my number line. Okay, there's my number line. So I am going to graph this x is less than -1 on my number line. And I'm going to have a parenthesis because it's just less than. It's less than -1. And I'm going less than. Okay. On the same number line, I am going to do x is greater than or equal to 3 on the same number line. Okay? So I have a bracket there because it's the or equal to sign. And then I'm going to the right. So what I have done here is I have graphed this on the same number line. I've graphed it. Now, what I want to do is take my number line and write it in interval notation. So now, remember, when we're writing in interval notation, we have to start down here. We have to start down there. Okay? What number is way down there? What number is way down there? Negative infinity. Okay? That's where we have to start. We have to start at negative infinity. So I'm going to have negative infinity, and I'm going all the way to the number -1. Okay? So in red, what I have written down in red is x is less than -1 and the blue graph. But I want to join that with my orange. I want to join this. Okay, so the way that I join it is that union right there. That's what that means. The U means or. And so now I start at +3, and I made a mistake. Does anybody see what my mistake is? What did I do? Okay. What did I put right here, and what should I have put? It's supposed to be a bracket. Good. So I've got to fix that. So it's supposed to be a bracket. And I go from 3 to infinity. So I want to point out just a couple things right here. Okay? This is written as an inequality right here. X is less than -1 or x is greater than or equal to 3. That's an inequality. This is my number line. And I have graphed this using my number line. I've graphed it using my number line. This is my answer in interval notation. That's what this means right here. It's interval notation. All three of these are telling us the exact same thing. But you want to make sure that we are putting it in the form that our directions in our course is asking for. Okay? That's what you want to do. Okay? Can I go to the next screen? Oh, you know what? Actually, I want to talk a little bit about and or first. So when we talked and when we stood up, so whenever we've got two inequalities joined by the word and, we must meet both criteria. Okay? We must meet both criteria. When we are joined by the word or, you must meet either criteria. Must meet either criteria. Okay? Can I go to the next screen? Awesome. Okay. I think we just graphed this. Did we just graph this?
Yes, we did.
We graphed something extremely similar. So what we're going to do now is we're going to go to this screen. So this is combined. Oh, no, we didn't.
Oh,
My
yeah.
bad. Okay, so we're going to talk about this one because this doesn't say or. This says and. So I've got to have a number greater than -1, and that number must also be less than 3. So just think about that right now. Who can raise their hand and tell me a number that meets both those criteria?
2. Sorry.
That's okay. 1, 2, 0. What about -1/2? Does that meet that criteria? Okay. Thumbs up, thumbs down. Does -1 meet this criteria? Yes for thumbs up, no for thumbs down. Does -1 meet the criteria of x is greater than -1 and x is less than 3. Okay, so I've got a couple up and a couple down. If you've got no clue, you can just do this and say, I got no clue. Okay, thank you for the no clues. I appreciate it. Okay, -1 does not meet this criteria. Okay, and let's talk about why. Why does -1 not meet this criteria? Okay?
Because it's not greater than. Well, I mean, not greater than is not equal to.
It's not or equal to. Okay? Now, would -0.99999 meet this criteria? Yes. Okay? But -1 does not. Because it says x is greater than -9. Okay? For -1 to meet this criteria, we would have had to have the or equal to sign. That's what we would have had to have. Now, let's focus on graphing this and figure out what it looks like when we graph this. Okay? So I'm going to draw my number line. That's not a very good number line, so let's try again. Okay. So here's 0. Do you guys like my new toy? I downloaded a free trial. I'm like giddy. I'm so excited. Yeah, it's kind of cool. Okay, my husband he pretended to be amused last night when I showed him at like 9:30.
Pretend to be amused. It was just like, oh.
He was like, oh, that's cool, honey.
How cool.
Yeah. Okay, so what I'm going to do right now, I've got my blue. Okay, so I am going to graph x is greater than -1 in blue. Okay, so I'm going to have my parenthesis at -1, and then I am going greater than. So my blue is showing that x is greater than -1. Now in orange, I'm going to do x is less than 3 in orange. So here, whoops, there's 0, 1, 2, 3. Here's 3. Okay. Now, my solution to this, because of the word and, because we have the word and, is only the area that's covered by both. It's only the area that's blue and orange. So if I were to write this in interval notation, my answer is only the part covered by both. So I start at -1, but the parentheses shows that -1 is not included. That's what the parenthesis is showing, that -1 is not included. And I go all the way to 3, and I have a parenthesis at 3. So when we are talking about and, our interval notation answer looks like what? What does that look like? A graphing point. That's called an ordered pair. Got to learn to stay away from this Doceri desktop trial. Not doing a great job of that yet. Okay? Our interval notation answer looks like an ordered pair, but this is not an ordered pair. What this interval notation answer means is we're talking about all numbers in between -1 and 3. That's what that means. So the word and, your answer looks like an ordered pair, and it's talking about these numbers, the numbers in between -1 and 3. That's what those mean. Okay? Can I move off the screen? Yes, sir.
If the x is greater than 1, if that were x is greater than or equal to, and the x is less than 3 was the same, would we still use parentheses or would we use brackets?
That's a great question. Okay, that's an excellent question. So the question is, if I had x is greater than or equal to -1, and x is less than 3, okay? You would use a bracket here, and you would use a parenthesis here, okay? So in this scenario right here, because the -1 has the or equal to, then we have the bracket here. So you can have a bracket on one spot and a parentheses on another. Excellent question. Thank you. Okay? Can I move to the next screen? Okay. Now, oh, I still didn't fix it.
We'll start calling the integral notation of and fake news order pairs, dude.
We are not going to get political. Okay. What I want you to do right now is I want you to solve both of these. You know how to solve them. When do we reverse the inequality sign? When do I reverse the inequality sign?
If you are multiplying or dividing by a negative.
Can you tell me?
When you're dividing by a negative?
When you divide both sides by a negative or you multiply both sides by a negative. Good. Good job, too. Okay? So I want you to solve both of these. Solve both of them. Okay? I'll give you about 1 minute to solve both of them. Okay, so we're going to subtract 1 on both sides. I'm left with 3x is greater than -6. Okay, divide both sides by 3. Do I reverse? No. Tell me why. Because I'm not dividing by a negative. There's a negative on top here, or my numerator, but that doesn't matter. I reverse the sign only when my negative's in the bottom. Good. I think you were the one that told me, so good job. So it's x is greater than -2. And I subtract 5 from both sides. Okay. Did you get x is less than 1? Did you get that? Good. So if I were to graph this, and the graph always helps us, it always helps us write it in interval notation. Okay, so I'm going to do x is greater than -2. And then I have x is less than 1. So I'm going to put a parentheses at 1. Okay. My answer, my solution is only this area right here. Where they're both shaded. Okay? So because I'm using the word and, I'm going to start at -2 with a parenthesis. And I'm going to go to a +1. Okay? Okay. This is a compound inequality using the word and. And very often it will look like this right here. It's also possible that you will see it look like this. Okay? That you will see it look like this. So when you look at this, I want you to think about this as having 3 sides instead of 2 sides. Like typically we do the same thing to both sides. So for this, we're going to think about my left-hand side, my middle, and my right-hand side. I'm going to think about it as 3 sides. My goal here is going to be to isolate the variable in the middle. Okay? So we want to isolate that variable in the middle. We want to get it all by itself in the middle. Okay? When you see this type of problem right here, it always means and. So your answer is probably going to look like an ordered pair in this situation right here. Your answer is probably going to look like an ordered pair. Okay, so I've got 3x plus 1 in the middle. I want to isolate that x in the middle. So I am going to subtract 1 from the middle. And if I subtract 1 from the middle, I have to subtract 1 from all 3 areas. So I'm going to subtract 1 here and here. So I did it in all 3 areas. Okay, so now I've got negative 4 is less than 3x is less than 6. Okay. Want to get the x by itself in the middle. So I'm going to divide by 3 in the middle. And if I divide by 3 in the middle, I have to divide by 3 everywhere. Okay? So my answer is negative 4/3 is less than x is less than 2. Okay, now, when I graph that, it's okay if you graph this thinking, okay, well, negative 4/3 is about right here. 2 is here. And that's my answer right there. So if I write it in interval notation, I've got negative 4/3. That's my answer. Negative 4/3, comma 2 in interval notation. A lot of times students will look at this part right here and they'll say, but Alicia, isn't that going the opposite way? You have to read that backwards. Do you remember how on Monday or Friday I said always move your variable to the left when we were solving inequalities? This is why. Because right here, you've got to read this backwards. You've got to say x is greater than negative 4/3. What this is saying is negative 4/3 is less than x, which is less than 2. So if I were to rewrite this, I would rewrite it as x is greater than negative 4/3 and x is less than 2. So you have to be careful with that. This is an example of why we move our variables to the left. Okay? Now this is something that you'll see, in college algebra and then some of your calculuses. But you won't see this a lot in this class, but I wanted you to be exposed to it. I wanted you to see it, know that it might be on your homework, just so you can be exposed to it. Okay? So let's look at or. Can I move off this, or does anybody need a picture before I move off of it? You only reverse it when it's in the middle, like right here. So in this type of problem, yes, you would always reverse the one on the left. Yes. Great question. Okay, here we go. So we have done one similar to this. But I like to practice writing in interval notation, and that's what's super helpful here. So I am going to do both of these on the same number line. I'm graphing both of these on the same number line. Okay? So my first one is I have x is less than negative 1. And then my second one, x is greater than 2. Now, so I have it written in inequality form. I have it graphed. And now I'm going to write it in interval notation. I'm always going to start on the left, the furthest left. Your interval notation has got to be in the same order as your number line. So I'm going from negative infinity on my number line all the way up to negative 1. Okay? Now, this is the wrong way to do it. This is why it's helpful to always graph it first. I am not doing negative 1 to negative infinity. Okay? This is wrong. Okay? This is the wrong way. But students do this all the time. That's why it's helpful to have the graph. When you are looking at the graph, you know that the graph starts at negative infinity. If you do the graph, you typically don't do this. You only get this when you just look at your inequality of x is less than negative 1. Okay? So please understand, if you were to flip this and write it negative 1 to negative infinity, that's incorrect. You've got to put it in order that you come to it on the number line. So you always start at negative infinity. So you've got negative infinity to negative 1. Then I put the u there to show my union. Then I start again at positive 2 and go to positive infinity. Okay? Now I want you to try one. And I'm going to give you 3 minutes to do it on your own. Okay? 3 minutes to do it. So you've got 2x minus 5 is less than negative 11. Or 5x plus 1 is greater than or equal to 6. Okay? Okay. So when we solve the inequalities, I'm hoping that you got x is less than -3 or x is greater than or equal to 1. Okay? I'm hoping that's what we got. You did not need to reverse either one of these signs, and the reason for that is because we divided by +2 and we divided by +5. Okay? That's why we didn't need to reverse either one of those. Now, on x is less than -3, I start at -3 and I go less than. On x is greater than or equal to 1, I start at +1. And did you catch what has to be there? What has to be there? Good, good. And that's because of the or equal to sign. So this is another one of those situations where you're going to have a parenthesis on one number and you're going to have a bracket on another. And that's okay. That's okay. So to write it in interval notation, I have to start at -infinity. And I go to -3. Okay, my U means union. And then I go from 1 to infinity. Okay? So the interval notation is the final answer that we're looking for. Okay? The interval notation is the final answer that we're looking for. Because you are going to have to put things in interval notation. The number line helps us get there. Oftentimes the number line will not be part of your answer, but it helps us to get there. That's why it's helpful. Okay? Can I move to the next slide? You good? Okay. Before we leave, we are going to now switch gears and we're going to talk about absolute value. Okay? On Friday, we are going to talk about more absolute value, but we're going to start problem solving. We haven't done a lot with problem solving at all because I like to spend a full day just on problem solving. Okay? So on Friday and Monday, we'll be finishing up compound or absolute value inequalities. And we will be doing problem solving. And then we will review next Wednesday, and your test is next Friday. So no later than Friday, you'll have a review. So you'll have your review so you can start working on studying for your test. So right now, for the next 13 minutes, we are going to talk about absolute value equations. Absolute value equations. And absolute value equations are equations that involve the absolute value sign. Now, what I want us to remember about absolute value is the distance a number is from 0. Absolute value is the distance a number is from 0. Okay, so if I have the absolute value of -4, what does that equal? 4. Okay, and if I have the absolute value of 4, what does that equal? 4. So if I tell you that the absolute value of x is 2, there is a positive component that x can be, and there is a negative component that x can be. So when I simplify and I remove those absolute values, when I'm talking about x, I can have a positive value for what's inside those absolute value signs, and I can have a negative value for what's inside those absolute value signs. So in the absolute value of x equals 2, what could x equal? X could be, excellent. X could be 2 and x could be -2. Okay? Because if I plugged in, so if I went to check it, if I check x equals 2 and I plug 2 in for x, what do I get?
Still 2.
I still get 2. Now if I check x equals -2, If I plug negative 2 in for x, what do I get?
Even more too.
I get 2, okay? So when I am doing absolute values, I am going to have a case 1, okay? And case 1 is going to be equal to a positive number. Okay? And case 2 is going to be equal to a negative number. Okay? Case 1 and case 2 going to be equal to, you're going to have 2, you're going to split it. So whenever I remove those inequality signs, I'm going to have what's inside the inequalities equal a positive number. Then I'm going to have what's inside the inequality sign equal a negative number. Okay? This is a decent screen to make sure you've got all the information or you've taken a picture of it. Okay. So, in this situation, I'm going to write down, so before we do x plus 2 equals 5, if I tell you that the absolute value of x equals 5, case 1 is going to be that x equals 5. That's going to be my positive value. Then I'm going to have case 2. Okay, and case 2 is going to be a negative value. So what's x going to equal? Negative 5. Okay? Now, what we're talking about with case 1 and case 2 is we're talking about what's inside the absolute value. So in this situation, I'm talking about x plus 2. I'm talking about x plus 2. So for my case 1, okay, I'm going to remove the absolute values for case 1, remove absolute value signs, and keep number positive. I'm going to say keep equal to positive. Okay? That's for case 1. So in here, I'm going to have x plus 2 equals positive 5. Okay? Now, for case 2, I am going to remove absolute value signs and make the number that it's equal to negative. Okay? So I remove my absolute value signs and make the number that it's equal to negative. So for my case 2, I'm going to have x plus 2 equals negative 5. Okay? And I know how to solve both of these. Okay? So when I solve these, I've got minus 2. So I end up with x equals 3. And here I've got minus 2. And I end up with x equals negative 7. So this is the answer that I'm looking for. 3 can be positive, or x can be positive 3, or x can be negative 7. You might see that written like this. And this is a different kind of bracket. That's not a great bracket, but it kind of looks like this. And what this bracket means, it doesn't mean in between negative 7 and 3. It means only negative 7 and only 3. So you might see you might see your answer like this. Now, I want to erase this red down at the bottom because I want to check it, and I want to prove to you that these two numbers work. So have you written down the remove absolute value signs and keep it positive? Or does anybody need a picture of that before I erase it? That's what I'm erasing the red at the bottom because I want to show you that the check works. Okay, so I'm erasing. Okay, here we go. So now we're going to do the check. So I've got to check both of these. Okay, so I'm going to check x equals 3. So I go back to the original problem for the check. So I'm going to do 3 plus 2 equals 5. 3 plus 2 equals 5. What is 3 plus 5? I'm sorry, 3 plus 2. I apologize. It is 5, okay? And what is the absolute value of 5? 5. So this works. 5 equals 5. Now, my other one is I'm going to check x equals negative 7. So always go back to the original. So I have negative 7 plus 2 equals 5. What is negative 7 plus positive 2? It is negative 5. But the absolute value of negative 5 is what? 5. So do both of them work? Yes, they both work. Okay? Okay. Can I move off this page? Okay. I'm running out of time, so I need to show you this one next. What is different about this one than the one we just did? What's different? Okay? This one is different because my absolute value is not isolated to one side. Okay? Before I can do case 1 and case 2. Okay? Before I can do case 1 and case 2, my absolute value portion must be by itself. So before I do anything isolated, I hope that's right. Okay? So before I do case 1 and case 2, I've got to add this 3 to both sides. So I haven't done anything with my absolute value. I've just added 3 to both sides. So I still have 2x plus 5. Okay? All I did was I moved that negative 3 to the other side because it was outside my absolute value sign. Now I do case 1 and case 2. So case 1 is positive. So I have 2x plus 5 equals 11. And case 2 is negative. So 2x plus 5 equals negative 11. And I know how to solve that, right? Cool. Okay, I will see everyone on Friday. Have a good day.
Of course, I'm the type of dude to have 2 binders.